Previously, we covered an informal definition of limit. We mentioned that the main objective of the concept is to identify the behavior of the function as its independent variable x approaches a certain value. Now, we will use this definition as a basis on our approach to find that limit L, the number that f of x approaches as x gets close to the number c. This approach is called the numerical approach of finding the limit of a function. Recall that we previously defined the limit of a function using informal definition, that is, the limit of f of x as x approaches c means that f of x can be made as close as desired to L by making x close enough to c. Using this informal definition, we will now go through the steps of finding the limit of a function using numerical approach. We will do this in 3 steps. The numerical approach of finding the limit of a function, of course, is done by analyzing the pattern of numerical values. Therefore, we will be needing a table. The first step is to assign values to x that approaches c, because c can grow or can be approached from 2 directions. There will be 2 sets of values, one coming from the left and the other coming from the right. Note that these values are chosen and arranged in a way that they are getting close to C. Second, we evaluate f of x at each of the assigned values of x. This will give the corresponding values for the dependent variable y. Note that for the reason that will be discussed later, we do not evaluate f at c. Third, determine the value f of x seem to approach based on the generated values from the step 2. First from the left, then from the right. In this case, your intuition is needed. That's why we call it an intuitive approach. Note that it is important that f of x approaches the same number, say L, from either direction. If this happens, then bingo, we conclude that L is the limit of the function as x approaches c. Once again, to find the limit of a function using numerical approach, first we assign values for x. These values must approach c from the left and from the right. We then evaluate the function at each of these values. And lastly, we analyze the generated values and see if they seem to approach a certain number. If they do, then we say that it is the limit of the function at c. Let us apply this procedure. Example 1, let f of x be equal to 2x plus 1. Find the limit of f of x as x approaches 0. In symbol, we want to find the answer to that expression. Solution. So first, we need a table. Then place C in the middle. Note that in this problem, C is equal to 0. That one. Using the first step under numerical approach, we assign values of x from the left. So we can start with -1 and -0.8, -0.6, -0.4, -0.2, -0.1. So they're arranged in an increasing manner from -1, and it approaches 0 from the left. Then from the right, we can start with a symmetrical uh, order with respect to the values from the left. So we have 1, 0.8, 0.6, and so on until it goes to 0.1. In this case, it is decreasing from 1 going down to 0. Step 2, evaluate f of x. We will compute the corresponding values of f of x. So we start with that one. For x equals -1, we have f of -1 equals 2 times x plus 1. So x is -1. So we get -2 plus 1, and in total, -1. So we will write that in there. Next, when x equals -0.8, we have f of -0.8 equals 2 times -0.8 plus 1 equals -0.6. So we write -0.6 and there. If we do this computation, we use calculator, and what we will get for the rest of these values for f of x will be all right. That's a value that we get. And please do not hesitate to use calculator because we are not testing our ability to compute. Now we're dealing with calculus, so do use calculator. Final step, we will inspect the computed values of f of x. First, from the left, observe that the values are increasing from -1. Then we have -0.6, -0.2. It becomes positive now, 0.2, 0.6, 0.8. While on the right, we started with 3, then it goes down to 2.6, 2.2, 1.8, 1.4, and 1. So on this side, the values are decreasing, rather increasing up to something. And on this side, the values are decreasing down to something. At this point, we can claim that f of x is approaching a number in between 0.8 and 1.2, right? And based on this, it is not a bad guess to say that f of x is approaching 1 as x approaches 0, right? In between 0.8 and 1.2. So in that case, we write the limit of 2x plus 1 as x approaches 0 equals 1.
What if I am in doubt that it is the number 1 the function is approaching?
This is a great question, Julie. If in doubt, you can assign values for x that are even more closer to c, say 0 0.1, 0 0.001, 0 0.0001, and so on and so forth. So from the left, we just put negative, and from the right, positive, since c is equal to 0. So this ensures that the assigned values for x are, very much closer to c now. When we compute for f of x, so we get from 0 0.8 becomes 0 0.98, 0 0.998, 0 0.9998, very much closer to 1. And on the right side, from 1.2 becomes 1.02, 1.002, 1.0002. Yeah, very much closer to 1 now. So with confidence, we can now say that the limit of 2x plus 1 as x approaches 0 equals 1. Example 2, find the limit of f of x equals 2x minus 1 all over x minus 1 as x approaches negative 1. Solution. First, assign values for x from the left and from the right. Next, compute for f of x for each of these assigned values of x. So again, you can use calculator here because I used calculator when solving these values. As x approaches c from the left, this is the values that we get. The evaluated values of f of x exhibit an increasing pattern, right? So from 1.3331, it increased to 1.41177, then 1.47, 1.49, 1.499, 1.49999. Almost equal to 1.5, right? How about on the other side? What does this tell us? As x gets close to c, f of x decreases, and so we have what we get is 1.565, 1.545, decrease down to 1.52, decrease to 1.502, 1.50025, 1.50030. So really, really close to 1.5. So what is our fearless conclusion? The limit of f of x is approaching 1.5 as x approaches negative 1. Example 3. Solve the limit of cosine x as x approaches pi. Solution. Before we start assigning values for x, we first recall the first few digits of pi because this can be difficult or complicated if we are not familiar with these values. So these are the few digits. We have 3.14159265. So for values of x that approaches c from the left, we can assign 3.1, 3.14, 3.141, 3.1415, and so on. So here we start with these first two digits, then first three digits, and so on. And we are sure that they stay in the left and they are arranged in an increasing order, going up to pi. On the other side, we assign values from the right of pi, but this can be a little bit tricky. We need to come up with a decreasing sequence of numbers that approaches pi while making sure that they don't cross to the other side. But we can start with 3.3. Why not? Then 3.2. Are you getting the idea? Then 3.15, 3.142, 3.1416, 3.141593. They stay bigger than pi, but they're getting close to pi. So when we compute using our calculator, these are the values that the calculator will spit out. On the left, we have negative 0.39, then negative 0.4 or 59, very close to negative 1, right? And lastly, the computed values is negative 0. A lot of nines, so really close to negative 1. How about on the other side? Let us see. So negative 0.987, then it goes down to negative 0.998, then it really going down to, yeah, really going down to negative 1 as well. Okay, and given these values, I think we are now confident to say that the limit of f of x, which is cosine x, as x approaches pi equals negative 1. Next, investigate the limit of f of x as x approaches 1, given that f of x is defined to be 2 plus x when x is less than 1 or equal to 1, and 3 over x when x is bigger than 1. Solution. So we are asked to find the answer to this expression. But before we do that, let us first understand what this funny way of defining a function means. That one, the piecewise defined function. So yeah, this is a piecewise function. The reason why this is called that way is because it involves different pieces of expressions or functions, if you will, that are defined on their respective subdomains. It's the subdomains. Meaning, if we are to evaluate the function at any values less than or equal to 1, we will use 2 plus x. And on the other hand, for values greater than 1, we use 3 over x. So these are the values less than 1, and these are the values greater than 1. So we evaluate it here, 3 over x. Okay, very easy, right? No big deal. With that said, we are now ready to find the limit of f of x as x approaches 1. First, the table and the assignment of values. Second, compute for the f of x on each of these assigned values of x. And yeah, looking at these values, we can say that either sides are approaching what number? You have 1, 2.5, 2.7, 2.9, 2.99, 2.999. So it looks like they approach 3, right? And the same with the numbers, computed values of f of x from the right of C. Hence, we say that the limit of that piecewise function as x approaches 1 equals 3.
Is there a recommended set of numbers when assigning values for x?
Does f of x always approach a number?
What happens if the function approaches a number from the left of C, different from the number it approaches from the right of C?
These are excellent questions, actually. To answer Yvette's question, there is no restriction when it comes to assigning of or to assignment of values for f of x. You can freely choose a set of numbers that you want as long as these numbers are close enough to C. Remember, the goal is to understand the behavior of the function in the vicinity of C. So might as well choose values that are really close to C. Meanwhile, there is what they call the standard table of values, where the assignment of values for x is given by that one. The entries in this table are arranged in an order that is getting close to C. You can see here that the values of x is just here is just 0.000001 away from C, right? So for the next question, does f of x always approach a number? The answer to this question is no. In fact, we will devote one whole episode just to discuss the conditions when the function does not approach a number as x tends to C. Next question, what happens if the function, next question is, where's that? What happens if the function approaches a number different from the left of C, different from the right on the other side? So the case when the function approaches two different values from the left and from the right is also a case of a function that have or that has no limit or not approaching a number at all. Again, an extensive discussion about this will be given in the coming episodes. Example 5, use the standard table to find the limit of f of x equals x cubed minus 1 all over x minus 1 as x approaches 1. So this is the recommended, not really recommended, but a suggested values for assigning uh, values for x. Okay, so solution. Following the standard table, because c equals 1 in this case, the first entry for the values of x from the left would be 1 minus 0.1. So that will be 0.9. Then the second one is 1 minus 0.01. That will be 0.99, and so on. So really getting close to. While on the other side, so c plus 0.1, that would be 1.1. C plus 0.01, that would be 1.01, and so on. Okay, very easy. Solving for f of x, given this set of values assigned, we get thanks to calculator, computation becomes as simple as this. So, nice. We have a very revealing pattern. Each side seem to approach 3, don't they? Yeah. So if you agree with me, at this point, we may say that the limit of x cubed minus 1 over x minus 1 as x approaches 1 equals 3.